Welcome to the Deep Dive. We are back at it, and today we're tackling a topic that I think suffers from a serious PR problem. We're talking about Azure storage.
Mm-hmm.
And I know, half the people listening probably just rolled their eyes and thought, great, 20 minutes on hard drives.
It's the classic utility trap, isn't it? It's like plumbing. Nobody thinks about the pipes until the basement is flooded.
Or in this case.
Or in this case, until the bill arrives and it's, 3 times what you budgeted for.
Exactly. But looking at the stack of research and exam guides we have for the AZ-104 today, it is so obvious that calling this storage is almost a disservice. It's not a locker for files.
Not at all. It's this massive, intelligent, distributed beast. If you go into the exam or a real-world architectural meeting thinking Mini, Azure storage is just a big USB stick in the sky.
You're going to have a bad time.
You're going to get crushed, yeah. We need to shift the mental model from saving files to managing a digital warehouse. We're talking availability, security, performance, and the big one, cost.
So that's our mission today. We are decoding the implement and manage storage module. We're going to break down the accounts, the weird naming rules, blobs, keys, and how to stop a meteor strike from deleting your data.
A meteor strike is a low probability event, but definitely high impact. We should probably plan for that.
Let's start at the very front door then. Creating the container itself, the storage account. I was reading the rules, and there's one requirement that just seems wildly strict. The name.
Ah, yes, the global uniqueness rule. It trips everyone up the first time.
It says the name has to be, 3 to 24 characters, lowercase letters and numbers only, no dashes, no caps. And this is the crazy part. It has to be unique across all of Azure.
Not just your subscription, the entire planet.
Why? I mean, why is it so picky? My VMs don't have this rule.
It comes down to how Azure exposes it to the internet. When you create a storage account, let's say you snag the name Deep Dive 2026, Azure automatically creates a public DNS record. It becomes deepdive2026.blob.core.windows.net. Because that's a public global URL, the name itself has to be DNS compliant and, well, globally unique.
So you're literally carving out a subdomain on the public internet the moment you click create. That makes perfect sense.
Exactly. It's a namespace reservation.
Okay, so once we find a name that isn't taken, we have to pick an account type. The sources are pretty much shouting one recommendation here.
General purpose V2. Or GPv2. For the AZ-104 exam, or really any modern project, this is the default answer. It supports everything. Blobs, files, queues, tables, and all the new features like tiering.
Is there ever a reason to use the premium ones?
Oh, definitely. If you have a workload that needs extremely low latency, like single-digit milliseconds, maybe a high-frequency trading app, then you'd use premium blobs. It puts your data on SSDs.
But for most of us.
For 95% of use cases, GPv2 is the workhorse.
Okay, so we've built the warehouse. Now we need to fill it. Let's talk blob storage. The name, blob. It sounds like a 50s horror movie.
It stands for Binary Large Object. It's basically the bucket for all your unstructured data.
Unstructured meaning not a database.
Exactly. Images, videos, log files, backups, PDFs, anything that doesn't fit neatly into rows and columns. And the interesting thing about blob storage is its structure, or really the lack of it. It's a flat namespace.
See, this part confused me because when I open the Azure portal, I see folders. I see a folder called Images, and inside that, 2025, and inside that, vacation.jpg.
That is a very, very convincing illusion.
Wait, really? Folders don't exist?
Not technically, no. What looks like a folder structure is just part of the file name. The name of your file isn't vacation.jpg. The entire name is images 2025 vacation.jpg.
So the slashes are just characters in the name.
Exactly. The tools just parse those forward slashes and display it as a tree to keep us humans from going insane. If you delete that one file, the folders instantly vanish because they were never actually there.
That is a crucial detail. All right, let's talk about the money because this is where the managed part really kicks in, the access tiers.
This is the single most important concept for cost control. In the old days, a hard drive was a hard drive. In the cloud, the cost depends entirely on the temperature of your data.
So let's run through the menu. We've got hot, cool, cold, and archive.
Right. Think of it as a sliding scale. On one end, you have hot. That's for data you're hitting constantly. The storage cost is the highest.
High rent.
Perfect analogy. High rent, but the access costs, the transaction fees, are the lowest.
Got it. Then we step down to cool.
This is for data you access infrequently, stuff that sits for at least 30 days. The rent is cheaper, but you pay a slightly higher fee every time you touch a file.
And cold is just another step down.
It's a newer tier, yeah. Sits between cool and archive. It's for data you plan to keep for at least 90 days. Cheaper rent than cool, higher access fees.
And then we get to the deep freeze. Archives.
Archive tier is fascinating. The storage cost is dirt cheap. I mean, fractions of a penny per gigabyte. But the trade-off is massive. The data is effectively offline.
What does that mean practically? I can't just download a file from archive.
Nope. You have to rehydrate it first. You issue a request to move it back to the hot or cool tier, and that process, well, it takes hours.
Hours.
Hours. The system has to go find that data on slower, cheaper media and stage it for you. So if your boss runs in screaming for a contract you put in archive...
You better hope they have a long lunch break.
A very long lunch break, exactly.
That seems like a trap. I can't imagine going through terabytes of data manually every month and deciding what's cool.
You absolutely shouldn't. That's why lifecycle management is so critical. You just write policies, little JSON roles that automate the whole process.
So I can just tell Azure, hey, if a file hasn't been modified in 30 days, move it to cool.
Precisely.
Yeah.
And if it hasn't been read in 180 days, move it to archive. And if it's older than 7 years, just delete it. You set it and forget it. It's automated cost optimization.
That's beautiful. Okay, let's pivot from cost to safety. You mentioned the meteor strike.
Yeah.
How does Azure protect data from, hardware just failing?
It starts with the premise that hardware will fail. It's inevitable. So by default, Azure replicates every single object 3 times. The only question is, where do those 3 copies live?
And we have a whole alphabet soup of acronyms for that. LRS, ZRS, GRS.
Let's break them down by their blast radius.
I like that. So LRS.
Locally redundant storage. It keeps 3 copies, but they're all inside the same physical data center, usually the same storage cluster.
So if a single drive fails, I'm fine. But if the building catches fire...
Your data is gone. LRS is the cheapest, but it's the least durable against a real disaster.
Okay, so we step up to ZRS zone redundant storage.
Right. This uses availability zones. It still keeps 3 copies, but it puts them in 3 separate buildings in the same region. Separate power, separate networking, the whole deal.
So now the building can burn down and my data is still there.
Correct. But if a hurricane takes out the entire region, say all of East US, you're still offline.
And that's where GRS comes in. The big gun.
Geo-redundant storage. It replicates your data to a paired region hundreds of miles away. You get 3 copies in your primary region and another 3 asynchronous copies in the secondary, 6 copies total.
That sounds bulletproof.
Oh.
But there's a massive gotcha in the docs about GRS.
Oh, the read access issue. Yes. This catches people out all the time. With standard GRS, those copies in the secondary region are dark. You can't access them at all. You can't read from them. You can't write to them. They're an insurance policy for Microsoft to use if they declare a regional disaster and failover.
So wait a minute. I have a backup, but I can't actually verify it or read from it.
Not unless the primary region is completely gone. If you want to be able to read from that secondary region at any time, you need RAGRS.
Read access G-redundant storage.
Exactly. It costs a bit more, but it gives you a read-only endpoint in that second region. It's the only way to have true active-passive visibility into your backup data.
That seems like a critical exam question. RATNAGRS if you want to see the data. Okay, let's shift gears to Azure Files. This feels like the bridge from the on-prem world to the cloud.
It is. It's basically a managed file server. It speaks SMB, the Server Message Block Protocol, which is the native language Windows uses for shared drives.
So I can take a legacy app that expects to read from the S drive, point it at an Azure Files URL, and it just works.
That's the lift and shift promise.
No.
But there is a common networking hurdle that drives new admins crazy.
Is this the port thing?
It's the port thing. SMB communicates over port 445.
And let me guess, ISPs and firewalls are not big fans of port 445.
Not at all. Historically, older versions of SMB had some nasty vulnerabilities, so most residential ISPs and a lot of corporate firewalls just block port 445 outbound by default.
So if I'm at my home office and try to mount an Azure file share?
It'll probably fail. It'll just hang in timeout. It works beautifully between VMs inside Azure, but over the public internet, it's a real hit or miss.
Good to know before I spend hours troubleshooting. Now, what about Azure File Sync? This seems to solve that problem, right?
It's a hybrid solution. You keep a Windows server in your local office and you install the file sync agent on it. But the killer feature is cloud tiering.
I love this concept. This sounds like magic.
It kind of is. It basically solves the disk full problem forever. You set a policy like, only keep files on this local server that have been accessed in the last 30 days.
But the users still see all the other files.
That's the trick. The file name and icon are still there. It looks like a normal file, but it's really just a pointer, a stub. When a user double-clicks it, the agent instantly streams the content down from Azure on demand.
So the local server becomes a high-performance cache.
Precisely. You get local speed for your hot files and infinite cloud capacity for your cold files.
That's just smart.
Oh.
Okay, let's talk security. We've built the warehouse, we've filled it up. How do we lock the doors? The docs talk about access keys.
Think of access keys as the root password, the keys to the kingdom. Every storage account gets 2 of them, key 1 and key 2.
And they give you full control.
Total control. Delete, create, modify, anything. And because they're so powerful, the golden rule is you never, ever hard code these keys into your applications.
I feel like there's a story there.
Thousands of them. A developer accidentally commits a key to a public GitHub repo. Scrapers find it in seconds. Suddenly your storage account is hosting malware.
So, why are there 2 keys?
For rotation, it lets you change the locks without any downtime. You tell your app to use key 2, you regenerate key 1, then you switch the app back to the new key 1.
Okay, so if we can't use the master keys for apps, what do we use?
We use a SAS token, a shared access signature.
I like the analogy of the valet key.
It's a perfect fit. The valet key lets someone park your car, but it doesn't let them open the glove box. A SAS token is a string you append to a URL that grants very specific permissions for a limited time.
So I can generate a token that says you can upload a file to this container, but only for the next hour.
Exactly. And when that hour is up, the token is useless. It just expires.
What if I mess up and give a token to the wrong person? Can I revoke it?
You can. The SAS token is signed by the access key. If you regenerate that access key, it immediately invalidates every single SAS token that was created with it. It's like a global kill switch.
Okay, what about the network layer? Storage accounts have a public endpoint by default. That sounds a bit exposed.
It is public, but it's still authenticated. You need a key or a token. But for real enterprise security, we want to lock down the network path itself.
The sources mention firewalls, service endpoints, and private endpoints. The difference between those last 2 always confuses me.
It's a common point of confusion. A service endpoint is like a secure tunnel. It tells your virtual network, when you talk to Azure Storage, don't go out to the public internet, stay on the Microsoft backbone. The storage account itself still technically has a public IP, though.
Okay, and a private endpoint.
A private endpoint moves the storage account inside your network. It literally gives it a private IP address, like 10.0.5 from your own VNet.
So it becomes completely invisible to the internet.
Completely. You can only reach it if you are inside that network or connected via a VPN. It's the gold standard for security.
But that makes it crystal clear. Private endpoint equals private IP. Got it.
Yeah.
Let's wrap up with the toolbox. What tools do we need to know?
2 main ones. First, Azure Storage Explorer. It's a desktop app, really visual. It's fantastic for just browsing your data, uploading a few files, and testing those SAS tokens we just talked about.
And for the command line warriors.
As copy. If you are moving serious amounts of data, you use as copy. And there's a really important technical detail that makes it so powerful.
It's not just a copy-paste tool.
Not at all. When you use as copy to move data from one storage account to another, it performs a server-side asynchronous copy.
In plain English, what does that mean?
It means the data flows directly from Azure Data Center A to Azure Data Center B. It does not download to your laptop and then re-upload.
Ah, so I'm not the bottleneck.
You are not the bottleneck. It uses the massive Azure backbone. It's incredibly fast and resilient.
So we've covered the container with storage accounts. We've looked at the layers with the access tiers, hot, cool, cold, archive.
We covered the insurance with redundancy, remembering the RAGRS twist, and the keys with SAS tokens and network security.
It really feels like an active system. If you just dump data in there and walk away, you're doing it wrong.
You definitely are. You'll end up paying for hot storage on files nobody's touched in years, or leaving endpoints open. Administering storage means actively managing that lifecycle and security posture.
Before we go, is there one last thing we should leave people thinking about? A provocative thought.
There's a concept that's becoming huge for compliance and security. Immutability policies.
Commutability.
Making data unchangeable. It's often called worm write once, read many. You can lock a container so that files cannot be modified or deleted for a set period of time. Not by you, not by a hacker, not even by an admin with the root keys.
That sounds amazing for ransomware protection. If I can't delete it, the malware can't either.
It is the ultimate defense. But here's the tension. What about privacy compliance? Imagine a user in Europe submits a GDPR request demanding their personal data be deleted immediately. But you have that data locked in a container with a 5-year immutability policy.
Oh, wow. So you have a legal obligation to delete it.
And a technical impossibility of deleting it?
That's a conflict.
It's a major conflict between security and privacy that every architect has to think about before they click that lock button.
That is a headache I'm very glad we identified now rather than later. A really fascinating problem to solve.
Indeed.
Well, that is all the time we have for today. I encourage you all to go check your home network, see if port 445 is open. You might be surprised. Thanks for listening to this deep dive into Azure storage.
Happy learning!